In previous videos, we discussed alternating current and half wave rectification. Now, today we will be discussing full wave rectification. The first thing that we need to understand, why do we need full wave rectifier? As we remember, in half wave rectifier, half of the wave is actually passing through the diode and half of the wave is being stopped. It means that by default there is a loss of 50% of energy because wave is a mechanism by which energy is transferred. Plus, diode has some resistance, there must be some additional power losses. It means that the overall efficiency of half wave rectifier is around 40-41%. To avoid these losses, we need to have a full wave rectifier. The full wave rectifier that we will be discussing today is known as bridge rectifier. In bridge rectifier, what we do, we will take four resistors and then connect them in a closed loop, something like this. This is diode 1. Then we have another diode. This is diode 2. Then we connect another diode here and call it diode 3. And the last diode is diode 4 that will be connected something like this. Now the four diodes are actually connected in a closed loop. Now, what we will be doing, there are four nodes or four junctions. Across two opposite junctions, we will connect a power supply, that is alternating one. And across two opposite junctions, we will be connecting a load resistor across which we will be getting the output voltage. So first thing, I'm picking this node and connecting an alternating power supply, the other end of which is connected to the opposite terminal. Across the remaining two terminals, we will connect a load resistance across which I will be getting output voltage. Now, since we know that alternating current is the one that keeps on alternating between positive and negative, so current will acquire some form like this: positive, negative, positive, negative. Now, in the first half cycle, when we will be having this portion of the current that is positive, this end will become positive, this end will become negative. We know that current always travels from positive to negative. Regarding diode, we must remember diode conducts electricity in only one direction, that is from P type to N type when it is forward biased. So what will be happening? Diode will conduct electricity from P to N in this way. Current will be moving from P positive to negative, so it will reach this point. After reaching this point, current has two paths to travel. Either it can move through D1 or D2. But if you look closely, D1 is reverse biased because N of the diode D1 is connected to positive. And on the other end, D2 is forward biased, so current will pass through D2. After reaching this point, diode can pass through either D3 or V out. But if you look at D3, D3 is once again reverse bias. So current will pass through load resistor, something like this. After reaching this point, current can pass through D1 and D4. About D1, we have already decided it is reverse bias. So current will pass through D4, and after passing through D4, the current will keep on traveling because D3 is reverse biased and it reaches this terminal. That's how current is traveling. Now, if you look at the direction of current across resistor, current is traveling from right to left. So it means that this end of the resistor should be treated as positive and this one is negative. Now, this is all about the first half of the alternating current cycle. In the next half, what will be happening? This current, which I'm shading in green on sinusoidal curve, will be passing. So this end will become negative and this will become positive. Now current always travel from positive. So what will be happening? Current will acquire some path like this. After reaching this point, current have has two different paths to travel, either D3 or D4, but D4 is reverse bias because N of D4 is connected to positive. So current will pass through D3. After passing through D3, it cannot pass through D2 because D2 is reverse bias. It will again pass through load resistor. Now, current will pass through D1 because about D4 we have already decided it is reverse bias. It will pass through D1 and then it will enter this negative end. In this whole thing, if you look at the direction of current across in load, it is actually again right to left. It means that this is positive and this is negative. So we can say no matter what, the direction of current in load resistor is same all the time. So the output that we will be receiving for first half, it will be like this. And even for the second half, it will be like this. And the process will keep on repeating and we will keep on getting unidirectional current that is actually DC. And if you look at this direct current is actually pulsating. Why it is pulsating? Because it will keeps on fluctuating. It keeps on changing its value. But all the time it is remain in positive direction. So this is DC. That's how we perform full wave rectifier. As we can see, there is no loss of energy. So there must be some power losses because of resistances and everything. But the loss of energy that we were incurring in half wave rectifier won't be happening here. Now, one more thing that we need to discuss here. If you look at this DC, it is actually fluctuating. So what we do, there is a process which is known as smoothing. I hope you remember when we were discussing transistors, in fact, capacitors, we discussed the idea of smoothing. What we do, these are the two terminals across which we will be getting the output. We may connect this output to a capacitor and there is a load resistor. Now, we know that capacitor is a device that is used to store electrical energy. During positive cycle, it will be charging. During negative cycle of the current, it will be discharging. So what will actually happen? If we are using capacitor, let's say the output from the full wave rectifier was like this. We got a peak in positive, then we were getting something like this. Just add one more. So now what is the advantage of capacitor? Because of capacitor, after reaching this point, current will acquire some form like this. So what is the purpose of capacitor? A capacitor across the output from the full wave rectifier circuit actually reduces fluctuation of the rectified direct output voltage. And this process is known as smoothing. During the positive cycle, capacitor was charging, and during the negative cycle, it will discharge, providing steady voltage or current to the output resistance or the load resistance.